weak scaling. So when we consider Amdahl's law previously, the ratio between the parallel and the serial part was constant. And John Gustafson has been actually arguing that when you increase the problem size, usually increase the time spent into the parallel part of the execution compared to the serial part. So the potential for speedup is increasing while you're increasing the problem size. And this is what's called the weak scaling. So let's take an example. So if I take this code here, the complexity of the serial part is n. And when I take the parallel part, the complexity in here is n squared for the parallel part. Meaning that when n increases, the proportion of time spent into the serial part is decreasing, where the time spent into the parallel part is increasing. So the potential for speedups, for more speedups, is increasing as n is increasing. Let's look at a curve that shows that. So if I have a small problem size, so problem size of size 1, let's assume this gives me a 50% time spent into the serial part and the parallel part. My maximum speedup I can achieve is 2 here. Okay. But as I'm increasing the size of the problem, I get more and more time spent into the parallel part, and my potential for speedup is increasing. And if I keep increasing my problem size, I get more and more time spent into the problem size, into the parallel part. And so my potential for speedups keep increasing as I am increasing my problem size. So Gustafson explains that if you want to use bigger parallel machine, you have to increase the problem size you're dealing with. And it makes sense. Usually you want a bigger machine because you have a bigger problem to solve. So an application is going to show weak scaling when the amount of parallel computation grows more than linearly with the problem size. Okay, that was n squared before. And when you increase the amount of parallel work, you don't want to increase the management overhead. So the overhead of managing the parallel task should not grow very fast. So basically you would like to increase the size of the task, not the number of tasks you're dealing with, just to keep the overhead low, for instance. Two questions here. Give example of applications, algorithms that would show weak scaling, and examples of applications that will not show weak scaling. The reference, this is the original article from John Gustafson in 1988. You can see that Amdahl's law was from 1967. So there is 20 years, more than 20 years between both references. And see you in class.